Okay, to finish up our thoughts on proportionality and tables, let's focus on what tables can tell us about that constant and about being proportional. So it says use your understanding of the constant of proportionality. Remember that's a k. We find by going y divided by x. If the relationship doesn't have constant proportionality, label it as non-proportional. Now here's the thing. With all of these tables, they have to have the constant. Remember that constant means it's the same. The ratio of y to x must be the same for each one of these values. If even one of them is different, there's nothing wrong with that. It's just not proportional. So what we're going to do for all of these is we are going to, and I know it's not a ton of room here, but we're going to go y divided by x and see what we get. So I'm going to go 6.8, and I'm not going to write down all of them, but 6.8 divided by 2. See if I can use a calculator. I know this is hard to see here, but this is a 6. So if I go 6.8 and divide by 2, I get 3.4. Now I'm going to do it here. 17 divided by 5. 3.4. Okay? All I'm doing is dividing my y by my x. Don't just go in order. You got to make sure you're following the equation. Y divided by x. And then 27.2 divided by 8 and 3.4. Now don't get here and say, oh, I'm done, because they all have to have it. 37.4 divided by 11, 3.4. Is it okay to use a calculator? Absolutely. So we can determine that our constant is 3.4, which means this is proportional. Okay. All right, so now let's look at these values here. Again, we're going to do the same thing, y divided by x. Okay, so my y is 3 divided by 1. Well, 3 divided by 1 is 3. And then I'm going to go 9 divided by 4. That is a 4, not a 9. I'll pick up my pen here when I'm writing. Well, 9 divided by 4 is 2.25. So guess what? We don't even have to go farther. Now, if you want to prove something's proportional, you do. You have to go all the way through. But as soon as you find one that's not, you say it's non-proportional. Nothing wrong with it, but it's just doesn't have a proportional relationship. All right, so let's do the same thing over here. Y divided by x, 18 divided by 3. Well, 18 divided by 3 is 6. 30 divided by 5. 30 divided by 5 is 6. 42 divided by 7 is 6. 54 divided by 9 is 6. So in this one, our k, our constant, is 6, and we would say it's proportional. Now again, I said nothing's wrong with this problem here being non-proportional. It's just we can't necessarily apply some of the properties of things that we can do with being proportional. So it's important to judge, make the decision which one's proportional and not proportional. So from a table, you just got to test them all, unless you find one that isn't. Then you can stop and say it's not proportional. I know this next one kind of trips people up because it says a fraction. A fraction can always represent k in a proportional relationship. Because we don't like to deal with fractions, not because we can't, not because we don't want to, or, we don't want to, we tend to think we have to change problems when they're a fraction. You don't. This is your x column, this is your y. If you want to find the constant proportionality, your k, you take your y and you divide it by x. Actually, write that up here. It doesn't say your y as long as it's not a fraction. It just says whatever your y is divided by your x. So if you do that, that means I'm going to go 1/3 divided by 1. Well, anything divided by 1 is just itself. Then I'm going to go 2/3 divided by 2. And this is where it kind of trips people up because you're like, how do you do that? You can't have a fraction inside a fraction. Well, Yeah, but it's kind of a ratio. So what I'm going to do is I'm going to write it differently. I'm not going to write it like this. I'm going to write it like this. 2/3 divided by 2. So I'll write 2 over 1. And remember, when you divide by a fraction, you actually multiply by its reciprocal. Dividing by a fraction is multiplying by its reciprocal. Keep it, switch it, flip it. And then if you notice there, if you cross reduce, your 2's cancel out and you're left with just 1/3. Interesting. Now this one here, let's look at this. 3 over 3 equals 1. So I'm going to go 1 divided by 3. Well, guess what? That's already 1/3. How about 4/3 divided by 4? Remember, change how we write it. I'm going to write it as 4 over 1. Keep it. Switch it. Flip it. Oh, look it. Our 4's cancel out again, and I'm left with 1/3. And then 5/3 divided by 5. That works out to be 5/3 times, keep it, switch it, flip it. And we get 1/3 for that as well. So what is the constant here? It's 1/3. Even if it's fractions, we don't change how we do things. All right, then to finish up, each table shows a proportional relationship. Remember how we talked about before that when it says it's proportional, that's important. Because when it's telling us proportional, we know that it has to have the same rate. It has to have the same k. The y divided by x has to be consistent, has to be constant. So if we look at this first one here, it can kind of seem overwhelming on what to do. But look for, remember this is our x value and this is our y, look right here. We have this information right here. So we can figure out what our k is right there. And then use our k to find the other numbers. So I'm just going to go 78 divided by 13. Take a calculator. 13, and I get 6. Since we know it's proportional, we know that our k is 6. Now remember, what does that constant tell us? That constant tells us it's the number we're multiplying our x values by. So my y is going to equal 6 times whatever x is. So if these are x's here, 1 times 6 is going to be, nope, wrong ones. 1 times 6 is going to be 6. 10 times 6 is going to be 60. Notice I skipped these two because these two say that our y value is 24. So if our y value is 24, oh goodness, we need to say 6 times what number equals 24? Or you could think of it as 24 divided by 6. If you do that, you hopefully come up with 4. Same thing over here. 42 equals 6 times what number? 6 times 7. Okay, so for these, you have to just find the column you know. And here we know 2 of them. So this is my x column, this is my y. 15 divided by 6, 2.5. Is it okay to have a decimal? Sure is. In fact, if you even test the other one, 45 divided by 18, try that again. 2.5. So that means I'm going whatever's in this column, nope, I'm over here, whatever's in this column times 2.5. So whatever is right here times 2.5. Well, there's nothing there, so let's skip it. Whatever's here times 2.5. Now remember, we think of it going the other way as we go 60 divided by 2.5. Don't write it like that though. So if I go 60 divided by 2.5, I get 24. Now remember, what we're trying to do here is we're trying to figure out what number times 2.5. So here I'm going to go 75 divided by 2.5. 30. Now, for this missing one right here, where we're given no information, we're just going to use the idea of proportionality. If I double 6, that's 12. So whether you go 12 times 2.5 or doubling 15, you get 30 either way. All right. Now let's just quickly go through a couple more. X, Y. It's okay if we get a number less than 1. 12 divided by 15 is 0.8. So again, we're going to have to think of it in terms of dividing. 4 divided by 0.8. We get 5. Don't panic if that number seems weird, because remember, we're actually going 5 times 0.8. 5 times number less than 1 should be less than 5. Same thing here. 8 divided by 0.8. 10. Okay, and then we can use kind of the same thought as we did before. We can double 15 to get 30, and whether you go 30 times 0.8 to get 24, or you just double 12, you get it. Oh, last one. Let's see if you can see the green here. Right here is the one we need to know. 84 divided by 28 is 3. So our constant is 3. And this one you only have to check 1 because it tells us right here that they're proportional. That means they have to be the same. So 7 times 3 is 21. 35 times 3 is, I believe, 105. Yep. And then to go from y to x, this is where you have to divide. So I'm going to go 42 divided by 3. And when I do that, I get 14. And 63 divided by 3 is 21. So to kind of sum up our lesson, okay, we can use the constant of proportionality I'm going to try to spell it right. Proportionality to find missing values. And I'm just actually summing up, I guess, the last one here. We're just going to say to find missing values. And we also can see, and maybe I should include this, but I'm not going to change it. We also can use it to see if tables are proportional.